right, 5.6 is our last unit, our last section in Unit 5. So before Thanksgiving, we'll have all of Unit 5 done. When we come back, we'll get Unit 6 done before Christmas. So after Christmas, we'll have 2 months to get like 3 or 4 units done, and then we'll get into our trig book. Unit 5.6 is about the law of sines and law of cosines. We know how to use, hopefully have learned how to use sine in a right triangle. We've seen, we got so, ka, toa, right? So the so, sine, is opposite over hypotenuse. So in a right triangle, hopefully, since the last few days, that you know how to use the sine. And the sine ratio means your opposite side over your hypotenuse in the right triangle. Now, if it's not a right triangle, we could still use the sine button in our calculator. There is another way to use sines when we don't have a right triangle. This is personally one of my favorite sections because you can solve any kind of triangle now. It doesn't have to just be a right triangle. You could solve any triangle using our law of sines or our law of cosines. So here's a little example. Mark lives in Valley Oak Hall at CSUN. So this is actually a real map of CSUN's campus, partial of it. This is the track and field area. These are dorms. And the school itself is over on that side, if you had more of the map. My daughter actually lived right here for a year next to the track when I did the pole vaulting for CSUN. So I actually pulled a map off of that for CSUN. And it says that Mark lives in Valley Oak down here. And he's able to walk in a pretty straight line to Lupin Hall to meet his girlfriend, and it's about 125 yards. And his sister lives in Southernwood, and you can see that that's a pretty straight shot across to where his sister lives. It says, how far is he from his sister, this bottom line, and how far is his girlfriend from his sister, this top line. So we want to find these two parts of the triangle. So although trigonometry was discovered and developed using right triangles for so, ka, toa, right? And we can solve right triangles, so, ka, toa. It can also be applied to other types of triangles as well. And the blank right here, an oblique triangle, is one in which contains no right angles. So an oblique triangle is a triangle that has no right angles. Now we have special names for triangles. We have acute triangles, we have obtuse triangles, scalene triangles, isosceles, all that kind of stuff. Oblique just means there's no right angles in it. That's all it means. It's not a right triangle. Now your law of sines is right here. And let me lift this up so you can see it a little bit better. Law of sines is used to solve oblique triangles. Little a, little b, and little c represent the sides of opposite of angle A, angle B, and angle C respectively. Now the nice thing about law of sines, it's just setting up a proportion and cross multiplying. That's all it is. You're going to make a proportion with two of these sides, or two of these fractions, and you're going to solve it. You're going to multiply diagonals, you're going to divide, get your answer. So law of sines is one of the easier ones to solve for. It's just setting up a proportion and solving it. We might have the A's and the B's, and so we use the A's and the B's fractions, and we don't use the C fractions. We might have the A and the C, and we don't use the B fraction. You need to have 3 out of the 4 pieces in order to solve. You can't solve it unless you have 3 pieces out of the 4 when you're setting up a proportion. So it's just setting up a fraction and solving it. All right, let's look at the triangle on the next slide. We have the same triangle here. Okay, let's plug in our letters. Let's say that this side over here, this angle is angle A. And Lupin Hall is angle B. And then angle C is the one at Valley Oak. So where would little a go? Across from big A, which is 125 yards. That's going to be little a right there. Little b is down here, because it's across from angle B. Angle B opens up to side B, and then little c is across from side C. So little c is the top side. Now use law of sines. We want to solve this triangle. Which letter has both values? A does, right? A has the 28 for the degrees, and A has the 125 for the yards. So we have to use that fraction. Sine of 28 over 125. You have to use the one that has both values. So that's the first thing we look for, the one that has both numbers. So sine of 28 over 125. We're going to set that equal. And what other value do I have? I have B, right? So I'm going to have to use sine of B, sine of 50. And what letter then has to be the one I'm looking for? I got to be looking for little b because I have the sine of B on top. It's always got to be A over A, B over B, C over C. So that's going to be my proportion. So I'm going to be ended up multiplying the diagonal. So 125 times the sine of 50. That's going to be one side. That's going to equal the b times the sine of 28. Okay, so do you see I just multiplied the diagonals? This 125 times the sine of 50 and the sine of 28 times the b. Now in my calculator, I'm going to put 125, and if you have a calculator, you should practice. I would use one and practice it. 125 times the sine of 50, and that gives you a value. And in this case, it's 95.76. 95.76 equals b times the sine of 28. Now, how do I get b to be by itself? I got to take that 95, right, and divide by the sine of 28. So I divide both sides by the sine of 28, and I would end up with 203.96, which I'm going to round to 204. 204 yards. Okay, so I'm going to put that on my picture as well. 204 yards. That's going to be little b. That's side B. So now do you notice I have both A's and I have both B's? But I don't have any C's. How can I solve it if I don't have any C's? You got to find a C, one of the C's first. Which C could you find with the information you have? Not the side. Angle. You have two angles, and what do we know about all three in a triangle? Adds up to 180 for the angles, right? So you want to take, for angle C, you want to take 180 minus the 28 minus the 50. So you want to subtract those other two away from the 180 to see what's left over. And in this case, you're going to end up with 102 degrees. So that's going to go right down here at the bottom. So this is actually an obtuse scalene triangle, along with being oblique. It's oblique because it doesn't have a right angle. It's obtuse because it has an angle bigger than 90. And it's scalene because it's got three different sides. So it's obtuse scalene triangle. Now, could we use a squared plus b squared equaling c squared to get c?
Yes.
No. That only works in what kind of triangles? Right triangles. That's it. Only right triangles. It doesn't work in oblique triangles. Pythagorean theorem is equal when you have a right triangle. So that doesn't work here. So you have to do another law of sines to solve for little c. So we need to use big C, or angle C is going to be the sine of 102. Sine of 102 and over little c. So that's going to be one fraction. Equals. And then what other fraction should I put? Want to use A? Do we have to use A? No, you could use B, but A might be more accurate because remember we had to round B to get the 204. So they gave us 125 in the problem. I'd probably use what they give you in the problem. So I would probably use sine of 28, the sine of A, which is the sine of 28 over the 125. I usually like to use the ones they give you in the problem if you can. So there would be my little proportion to solve. Now you don't have to show all this work. All I require is that you write the proportion out because now you can do it all in your calculator. What two numbers do you think I should multiply together first? 125 times sine of 102. And when I get that answer, what am I going to do to that answer? I'm going to divide it by the one that's next to the letter, right? Which is going to be the sine of 28. So divide that by the sine of 28, and I can do all of it just in my calculator. I get 260.4. So little c is 260.4. So down on the picture, we can put 260.4, and we have yards there. Now you've got all of it solved for. You've got all three sides, you've got all three angles. Now look and see if it makes sense. Is the biggest angle across from the biggest side? Yes, 102 is the biggest angle, 260 is the biggest side. Smallest angle should be across from your smallest side. And that's true because 28 is the smallest and 125 is the smallest. So the triangle does make sense. So did you see how I got B? I used the proportion, cross multiplied. To get C, we subtracted them from 180. To get little c, we made a proportion again and solved it. Remember, you've got to have three pieces in your proportion. The two that you have for one the same letter, and then the one piece that goes with what you're looking for. So you got to have 3 out of the 4 pieces. Okay, you got your protractors handy, right? Now on your picture, there's a mistake. It should look like this. So cross out the 7 where it is and put it at the bigger side. Cross out the 7. Cross out the 7 where it's on your paper and put it as the bigger side. Because I messed up and put it at the wrong side. Now let's label our triangle. We're going to put A down here. We'll put B up at the top. We'll put C as the biggest angle. Usually we do it that way. It doesn't always have to be, but as a common rule of thumb we do. And that means that little a is which one? 4, good. And little b is what we don't know yet, right? And little c is our 7. So what letter do I have both values for? C, right? I got the angle c and I got the little c. So that you're going to have to put as one of your fractions. Sine of 110 over the 7. Well, that's got to be one fraction because you actually have both values for c. So put that down first. Equals. And then what are we going to need to look for? What other letter do we have? We have little a. So I need to find what next? The angle a, right? So I got to put sine of capital A over the 4. Remember, the sign's going on top, the numbers are going on the bottom. Man, just a side note, what if I flip them all around? Could I put all the little letters on top and all the signs on the bottom? Yes. Generally, we don't do that, but if you flip them all, it would be okay. You can't flip one and not the other. But I would just leave it with the sign on the top, the numbers on the bottom. Makes it easier to remember that way. All right, let's multiply our diagonals. So 4 times the sine of 110 equals 7 times the sine of A. So let me multiply 4 times the sine of 110. 4 times sine 110. I get 3.76. So if you multiplied these two together, you get 3.76 equals 7 times the sine of A. How do I get the sine of A by itself? Divide both sides by 7, right? So that's going to give me sine of A equals 3.76 divided by 7. and I get 0.537. So does that mean angle A is 0.537 degrees? That doesn't look like a 0.537 degree angle. Oh, don't we have to use inverse to get angles in here? And we're looking for an angle, so you do have to use inverse. So what we're going to do after you get your decimal, you're going to put sine -1. So put your little -1 there. And then put your parentheses and put 0.537 in the parentheses. So now I would plug that into my calculator. So I'll go your inverse and your sine, and then put in 0.537. We're going to see what angle would make the sine be a 0.537. And that angle would be a 32.47, which would round to 32.5 degrees. So 32.5 degrees would be angle A. So when we solved for sine, that gave me a decimal. So for us to go find the angle, we got to use the inverse sign to see what would make that decimal. The angle that would make that decimal would be a 32.5 degree angle. If I put sine of 32.5 in my calculator, sine 32.5, I'm going to get that decimal 0.537. Okay, so the 0.537, you put it in as inverse, it tells you the angle. So 32.5 degree angle, that's angle A down here, 32.5 degrees. Okay, now we've got both A's and both C's. What could we find next? Angle B would be the next thing to find because you can subtract them from 180. 180 minus 110 minus 32.5. And that's going to give you 37.5 degrees for angle B. So all I did was I subtracted those from 180. Took 110 away from 180, took 32.5 away from that, and you got 37.5 left over. So I'm going to actually put that value up in this angle right here, 37.5 degrees. So that's going to be angle B right there. So now we've got all three angles. We've got two sides. We cannot do A squared, B squared, C squared. It's not a right triangle. So I'm going to need another law of sine proportion. Which one do we need? Which one has to be there? We got to use the B, right? Because that's the one we're trying to find. So sine of 37.5. That one has to be there. And the B is what we're looking for. So on the bottom, you're just going to put a B. Sine of 37.5 over B. Which one can we use? We could use C, or we could also use A, but C is better because those were the two given ones. So let's go ahead and use C. So sine of 110 over 7. Bless you. Okay, so there's my new proportion. Now I'm not going to show all the work again. I'm just going to do it in my calculator. What two numbers do I multiply in my calculator first?
7 times sine.
Good. 7 times sine of 37.5. And what do I do to that answer? Divide it by whatever's next to the variable, right? So it's going to be divided by the sine of 110. So divided by the sine of 110, and you get 4.5 when you round it off. So that's going to be B right here, 4.5. Now check. Smallest angle is which angle? 32.5. Is A the smallest side? Yes, it is. 4 is smaller than 4.5. So C is the biggest angle, C is the biggest side. So it does work. So that's using law of sines to solve a triangle that's not a right triangle. If it's a right triangle, what do we use? We don't use law of sines. What do we use for a right triangle? Famous Indian chief SOHCAHTOA. If it's a right triangle, SOHCAHTOA. Right? If it is a oblique triangle, we use law of sines and law of cosines, but we aren't going to get to that till tomorrow. We're going to use law of sines. Okay, what I need you to do right now with your protractors is draw an acute triangle. Okay, draw a triangle. Try to make it acute so it's got all acute angles. And try to make it so that it's not equilateral or isosceles. Try to make it so you can kind of tell there's going to be three different sides. Two of them could be very close. But just draw yourself a triangle. I'm going to get rid of all this stuff. Hopefully you don't need it anymore. We're going to move it up. You needed it still? And then once you've got your triangle drawn, just make sure it fits down there. You want to make it be able so that you can check the angles with your protractor. So you should make it big enough to where you can possibly check the angles with your protractor. Okay, so what we're going to do after we measure or draw our triangle is you're going to measure one of the angles. So grab your protractor and measure any one of the angles. I'm going to measure this lower left angle. And I'm going to get 43 degrees. Now yours could be totally different. Should be different. You're making up your own triangle. I got 43, you probably got something different. So draw your triangle, measure the one angle. Now once you've got that angle measured, then you're going to measure the length of the side across from that angle. So if my angle's down here on the bottom left, I'm going to measure my right side over here that opens up to the 43. So grab your protractor that has the measurements on it and measure the side that's across from your angle. So basically you're going to have two of the same letter. I've got 6.3. 6.4 I'm going to call it. Okay, so I got 6.4 centimeters. You might have something totally different, but you should have centimeters. So what we have right now, we could call angle A, and we would then have little a over here. So you've got the two A's. Now pick one more angle to measure. Don't measure the third one, just measure one more of them. So I'm going to measure the bottom right angle for myself. It's easier. And that's exactly 70 degrees for me. Now yours is going to be different. So measure another angle. Any other angle you want, measure that angle. You might have to extend your line so that it'll go through your protractor so you can see an exact amount. If you got to make your lines longer, do it so you can see the exact measurement. I got 70. Yours will probably be different than 70. You made your own triangle. We're going to call that angle B. That means that little b is over here. Angle C is then going to be my third angle, so just put a C there. And little c will be the last side, across from angle C. Okay, your job is to solve the triangle with the law of sines and then check it with your protractor and see if you got it right. So use the proportions to find little b, subtract them to find big C, and then use the proportions to find little c, and then see if you got it correct by measuring it with your protractor and your ruler. See if you actually got them right. So you do the math work first, and then double check it with your protractor. And you can see the board. I'm going to do mine so you can see kind of the steps to take. I got to use the one that you have both letters. You got to use the A's first. You got to use the A's for your first fraction. So you're going to put your sine of A over your little a. So that's the side and the angle that you measured. And then you got to use the one that's across from B because you measured angle B. And then just do your calculator work. I'll do it on the computer here, so see it. I would do 6.4 times the sine of 70 for me. I gotta put 70 in first and then hit sine, and then equals. And then I'm gonna divide that by the sine of 43. So I gotta hit 43 sine equals, and I get 8.8. So my little b would equal 8.8 centimeters. For me, that's not yours. Yours could be totally different. The next thing you would need to find is capital C. I gotta take 180 minus the 43 minus the 70. And let's see what I get for that. Let's do it on the calculator here. 180 minus 43 minus 70. 67 degrees is my angle. So up here is going to be 67 degrees. Now I can find, once I've got the third angle, now I can find my last side because I can do sine of C over C. So I can do sine of 67 over the C equals, and I'm going to use the same one I used before, which was the A one, sine of 43 over 6.4. So I did sine of C over C equals the sine of A over A. Since I knew the angle A and the side A, I could use the sine of A over A. I could have also used the B's, but I like to usually use the ones that I start with that I measured or that they give you in the problem. So then you could just multiply 6.4 times the sine of 67, and then divide that by the sine of 43, and you'll get your little C. Now you got to multiply by your numbers. And I got 8.6. So I got 8.6 centimeters. Now, that looks like it might be pretty good because it's a little smaller than B, and B is across from a bigger angle, but it's not much bigger. Only 3 degrees bigger, so this is only a little bit bigger on the sides. So that looks like it might be right. So now take your ruler and measure the sides and see if you actually did get those correct. See if your law of sines actually worked. Should show that it works. For me, this should be 8.6, and if you look at it, it is pretty close. 8.5 is right there, and it just goes a teeny bit past 8.5, so that looks good for mine. And then I go up here and I measure the other one and see if it actually is 8.8. And yeah, 8.8 would be right up there, which is where the top of that side is. So that does come out good. The law of sines works great for oblique triangles, triangles that are not right triangles. You can use the proportions, solve them, and then double check with your protractor. You could even check your last angle with your protractor to see if it really was what it says it was. So for me, 67, nice, perfect there too, so that's good. And that's law of sines. Well, we're going to show you one last thing here. Okay, so you can finish that up if you need to. I do need to get to the last two little things here before we stop part one. We can use law of sines if we have two angles in one side, just like we had in the previous example and in the CSUN example. We can also use law of sines if we have two sides in one angle. just like we did on the other triangle that we drew right here. No, the one I deleted, sorry. You would have two sides and one angle. In this example right here, they gave us two sides and one angle. So they gave us angle U. So let's put in the angle U, 42 degrees. And then ST is 22. And SU is 12. So basically what we have is we have little u across from the big U, right? And we have little t is going to be the 12. That's going to be across from the big T. So little t is over here. And then little s is down here. Oops. Now it's asking us to find the measure of angle t and solve the rest of the triangle. We're not going to solve the rest of the triangle right now. You could do that if you want to on your own later. We're just going to get angle t. So what I'm saying is we're going to find this angle right here. This angle t. That's what we're looking for. Which two letters do I have both values? U. So I got to put sine of u, which is sine of 42, over the little u, which is 22. That has to be one of our proportions because it has both values. It's got to be one of our fractions. What has to be the other fraction? We've got to use the t's, right? So do I know angle t? No, that's what I'm trying to find out. So sine of t, and what I do know is the bottom is 12. Okay, what am I going to multiply in my calculator first? Okay, sine of 42 times 12. Good, let's do that first. Sine of 42 times 12 equals. And you get 8.02. Oh, no, not times 12. Yeah, it is times 12, yeah. Okay, and then what do I do to that number? Divide it by the 22, right? Divided by 22. And you get 0.365 when you round it off. And then you got to do your inverse, because that's not an angle right there, is it? No, now we got to do and underneath it put sine negative 1. So now you know to put an inverse. Sine negative 1. And your parentheses is going to be 0.365. That's what's going to go into your calculator. Some of your calculators you're going to need to put in the 0.365 first, then hit the inverse, and then the sign. Like if I did that on this calculator, I would have to put 0.365. Then I'd have to hit the inverse button. Then I'd have to hit the sign. And that would give me my 21.4 degree angle. If I do it on this calculator, I have to put in inverse sine first, and then put 0.365, and I'm going to get the same 21.4. So either way, you're fine. It just depends on your calculator. iPhone calculators and cell phone calculators are going to be more like this, where you've got to put in the 0.365 first, then hit the second button, and then hit the sign. So our angle is going to be at 21.4 degrees. So that's angle T. That was angle T that we were looking for right here. 21.4 degrees. All right, we could find S if we needed to. Then we could subtract these two from 180 to get big S, and then we could also find little s. But we're going to move to the last slide here for today. I'm going to talk about area. Now, you already know area formulas. An area formula for a triangle. What is the area formula of a triangle? Base times height divided by 2. That will always work. That formula will always work. But what do you have to use that formula? The base and the height. And what if you don't have the base and the height? Then you could use the law of sines and the sine function in our calculator to also find the area. It also works. Basically it works because you could bring down an altitude and make two right triangles. So that's why the sign will work. But there is a new formula that you could use if you have something like this triangle down here at the bottom. Okay, so we have is right here. Now, there's not one big long formula. That's three pieces right there. That would be depending on what side and what angles you have. If you've got side A and B, then you got to do the sine of angle C. If you've got sides B and C, then you got to do the sine of A. If you've got sides A and C, then you got to do the sine of B. So it just depends on, in your triangle, what pieces you have. You got to pick the one that actually works for your triangle. So it's a pretty short formula, but you got to find the one that actually works for you. One thing you need to notice, and that's underneath this little box right here. Each letter, A, B, and C, has to be represented once. You have to have an A, a B, and a C. And two of them have to be sides. So if I've got side A and B, then I have to have angle C. If I've got sides A and C, then I need angle B. So you got to have an A, a B, and a C in there. Basically, what you need is SAS. If you think about that down here, you need a side angle side. The angle needs to be in between the two sides. If you don't have SAS down here, where you've got three different letters, then you've got to use the law of sines to get one of these pieces so that you can have an SAS. So you've got to be able to have these right here. Now the formula is very easy to plug in once you have your three pieces. Last piece right here that you need is that this formula works better if you don't know the height of the triangle. If you know the height, then you use the original formula, base times height over 2. Always use that if you know the height. If you know base and height, just use that formula. It's just when you got something like this, it would take a lot of work to find the base and the height of that triangle. I would have to draw in some right triangles. I'd have to, try to figure out using SOHCAHTOA how to get the side, the height, and then how to get the base. And it would take a lot of work to do that. Or I could simply put A equals, let me make this a little bigger so you can see it. I could do A equals, and I could do 11 is one side, times 21, my other side, times the sine of 35, my included angle, and then divide it by 2. And I could put all that in my calculator and I'd be done. And I'd have the area. I wouldn't have to calculate the height and the base and all that stuff. I'd have it right there done. That's one formula that you could plug in if you've got the side angle side. Now, the reason that is because let's pretend that angle D was our A. Let's say that was angle A. Because that's the first letter. If we're going to have alphabetical order for DOG, what would be the alphabetical order? D would be first, right? G would be next. E and O would be last. So that would be angle A. This down here would be angle B. This over here would be angle C. So little a would be down here at the bottom. That'd be the 11. Little b would be the 21, and angle C is right here. So I'm using little a, little b, and the sign of C. Here's little a, here's little b, and here's the sign of C. And I'm just multiplying that and dividing it by 2. So when you do that, plug it in just as you see it. It's no special trick. 11 times 21 times the sine of 35 equals, and I just plug it straight in. And then I get that divided by 2, and I get 66.2 square units. Area is always in square units. So you would put UN squared. Now let me show you how that would work on the computer calculator. If you have a computer calculator, you'd have to do 11 times 21 times, and then you got to put 35 in first. And then you got to hit sign button. So you got to hit the 35, you hit the sign button, then you push equals. That'll be the top part. And then you take that whole amount and divide it by 2, and you'll get your 66.2. So it depends on calculator, whether you have one of these, or they have the computer one. Just depends on what you need to plug in first.